This activity ties together the equation of a line and motion. Set up the motion detector and display the output of the calculator as the volunteer walks away from the sensor. Following the data collection, the class works together to determine the equation of the motion. Okay, here we have the graph of Jane walking away from the motion detector. And it's time for us to see if we can come up with the equation of the line. So all of you are welcome to raise your hands and participate in this discussion. Let's go. Our objective is to come up with an equation that represents the graph of Jane walking away from the motion detector. So to the y equals screen, does anybody have a suggested slope to start with?
Positive 1/2.
So 1/2 x plus and a y-intercept?
3.
Okay. Why 3?
Because I started near, so the y-intercept is close to it, so it's small.
But it wasn't at 0, so 3.
Yes.
Your y-intercept looks right on. We need an adjustment to the slope. Emily? 0.75x.
Whoa.
Okay, so she got steeper. Go ahead and clear out the 1/2 x plus 3. Can you go back to the graph a second? I'd like to give you guys a chance to compare the line you have and make a refined guess about what you'd like to see on your next equation to approximate this. Will?
0.8x plus 3.
Now, why did you go to 0.8?
At the end, it seems to be, the slope seems to be a little too, not steep enough for the guess, and so it looked like Jane might have walked a little faster than that.
Okay. Mikey,
We could lower the y-intercept to 2 instead of 3.
lower the y-intercept to 2.
I think it's too low.
Yeah.
Now it's a little too
I think it'd be somewhere
low,
between 3 and 2.
Just make it steeper.
and we need to make it a little steeper. Okay, so suggestion, please raise your hand so I know who to call on.
Okay, how about 0.84x plus 2.7?
Whoa.
Okay, let's turn off the others because that one looks pretty close.
Whoa.
Anybody have any finer adjustment you'd like to make?
If you want to go really into detail, you could do 0.842.
0.842.
Because it's only at the top it needs to be a little steeper. If that does anything. A little better? That looks good.
That's pretty darn close.
Okay, great. That takes us to the next part of the lesson. For the second part of the activity, the volunteer walks toward the sensor. Great.
Thank you.
In plus 10,
Yes.
and let's hit graph.
Oh.
Looks like your slope is kind of close, and it looks like our y-intercept is a little bit off. Who's got another estimate? Jimmy.
I think it's more like 15 feet from where I started to where I
Okay,
ended.
so let's make it a different equation, please. What slope do you want? Do you want
Or I still like -1. Actually, you know what? Why don't we go negative 5 over 4x? I think that's closer.
negative 5/4 x?
Yep. Plus 15. Oh, my slope was more off.
Okay, your slope is steeper
Yeah.
than the other one. So instead of 5/4, do I have a suggestion for the change in the slope?
Maybe 4/5.
4/5? Great.
And maybe like 27.
Okay, plus 15.
Oh, that's pretty close.
Okay. So let's go back to y equals and turn off the
Never
first
mind.
3 graphs and look at the one that's pretty close. What you'd like to make now to that graph.
Mm.
What about the y-intercept? Does it look right? Does it look a little too high, a little too low?
Maybe move it to like 14 or 13.
Okay.
13. 13. Oh.
Okay, so now we've got it above and below. So we had 13 and we had 15. What do you guys think for your
I think we should try
y-intercept?
14 this time.
Okay, now rather than writing it as negative 4/5, would you write it as negative 0.8x?
That's really close.
That is really close. Would you turn the first one and would you turn the 2 that are in fractional form off? Okay, now let's take a look at your graph.
Wow.
Wow, we're off a little bit at the bottom. Anybody have any suggestion for changing that slope? Do we want to be more steep or less steep?
Less steep.
So let's take 0.8 and change it a little bit. I'll take a suggestion.
I think we try negative 0.7.
Negative 0.7. I think that's a drastic change. That's my. Okay.
Negative 7.75. I think.
Oh, I think you guys found it. The process is then reversed. Study teams will analyze a linear equation and determine the starting point and motion which will produce the equation's graph.
Okay, so we have part B, y equals negative x plus, plus 10.
Alright, so wait, the x-axis is the seconds, right?
Yeah.
And then
Y-axis,
would be feet?
feet.
Yeah.
Yeah.
Okay.
Which would mean the y-intercept would be how many feet away from the motion detector you would be, right?
So because this is
feet.
y equals
Yeah.
negative x plus 10, it's 10 feet
10
away from
feet.
motion detector.
Yeah.
detector.
And negative slope, we found out, was walking towards the motion detector.
Mm-hmm.
Okay. So to be able to do that, you'd have to start 10 feet away and walk towards it with a slope of 1 or negative 1. How would
So
you?
that would be negative 1 feet per second, right?
Yeah.
Or a foot per second if you're walking towards it.
Mhm.
Okay.
So you just have to be able to count as you're going, I guess. Try and keep a constant rate.
Or get as
Yeah.
close to a foot as possible.
Okay. So that's how we'll do that one.
Okay.
What about C? I don't understand that because it doesn't have a slope or anything. It's just y equals 6.
So the y-intercept is 6, so we have to stand 6 feet away.
Just not
That's
move.
it?
Yeah, you
Yeah.
just don't move, because there's no slope.
Okay.
That's easy. Alright. Alright, so we have a good plan for this then? We got what we're
Yeah.
doing? Alright, cool.
Okay.
We
Good question.
have our plan for how we're going to do this, but do you want us to try it right now?
If you're ready, we can try it.
Okay.
Alright, cool.
Okay, so for y equals negative x plus 10, each of these is 1 foot, so you're 10 feet away, right?
Yeah.
Okay. So try and walk at a constant rate, and we'll see if we can get it.
Looks like a nice straight line, good constant rate. So now you guys are going to work on the equation.
Okay.
Okay, I'll check with another group.